question says, identify each of the following as paramagnetic or diamagnetic. If the atom/ion is paramagnetic, how many unpaired electrons does it have? So the first thing to realize is that any unpaired electrons are going to be in the outermost orbital. So what we need to focus on is the outermost orbital. So if we look at oxygen here, it's in here, so it's in period 2, a p orbital, so it's in a 2p. So the outermost orbital is going to be 2p, 1, 2, 3, 4. The reason unpaired electrons are in the outermost orbital, if there are at all, is because the inner shells are full, and full shells do not have unpaired electrons. Said another way, for every spin up, there's a spin down. So when we're looking for unpaired electrons, we're looking for the spin paired or spin unpaired electrons. So what we need to do is we need to draw the 2p orbital, and we draw it out like this, and now we need to put the 4 electrons in, and they go in up, 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 down. So is this paramagnetic or diamagnetic? Because it has any more than 0 unpaired electrons, this is paramagnetic. How many unpaired electrons does it have? Is 2. So this is paramagnetic with 2 unpaired electrons. O2 minus. O2 minus is, here's O, and we're going to gain 2 electrons. So it's going to be, instead of 2p4, it's going to be 2p5, 2p6. So this is going to be 2p6. We can again draw our 2p orbital. Okay, and we can put in our 6 electrons. 1, 2, 3, 4, 5, 6. This is diamagnetic with 0 unpaired electrons. Diamagnetic means weakly repelled by a magnetic field, but it also means that there are no unpaired electrons. So paramagnetic is slightly attracted to a magnetic field, and it's not exactly ferromagnetic, but we don't need to talk about that. So this is basically how we would do this. A trick here is, if something is isoelectronic with a noble gas, it's going to be diamagnetic. Many ions are isoelectronic with noble gases, because that's what makes them stable ions. They're noble gas-like. They also happen to be diamagnetic, because they have the same electron configuration of a noble gas, where all the orbitals in the p are full. Whether it's a 2p or 3p, it doesn't matter. All right, let's look at K. K, the outermost electron, is a 4s1. This one, you could probably already guess, is going to be paramagnetic with 1 unpaired electron. But if we draw it, we have the 4s, because there's only 1 electron in there and it can hold 2, all right, it has to be unpaired, and it has to only be 1 because there is only 1 electron. K plus. K plus is going to lose that 4s1 electron, and it's going to be isoelectronic with argon. All right, it's going to lose this 1 electron. This is a full shell, so therefore has 0 unpaired electrons. So this one's going to be diamagnetic with no unpaired electrons, and it's basically going to have the same electron configuration as argon, much like this one has the exact same electron configuration as neon. So nonmetals gain electrons to be like noble gases, metals lose electrons to be like noble gases, all the way back from chapter 2 or whatever it was. Let's look at nickel. Nickel is right here. So the last orbital for nickel is the 3d. 1, 2, 3, 4, 5, 6, 7, 8. Remember, the d is one less. It's not the 4d, it's the 3d. So this is 3d8. How many d orbitals are there? Well, there's 5 d orbitals. So this is our 3d. We're going to put 8 electrons in there. 1, 2, 3, 4, 5, 6, 7, 8. So this is paramagnetic because it has at least 1 unpaired electron, and it specifically has 2 unpaired electrons, like so.